Today we'll be looking at Weac Chemistry Practical 2025. Here is the instruction guide to schools. So in this year's 2025 Chemistry Practical, we are giving sort for our quantitative analysis, and we are also giving sort for our qualitative analysis. In today's video, I will be teaching you how to prepare your reagent for your titration. You know, if you don't prepare your reagent very well, if you don't follow the accurate measures, you may end up making your student to fail if you don't prepare your reagent properly. I'm here to guide you on how you can prepare your reagent for your 2025 chemistry practical titration so that you can get an accurate endpoint. Without wasting time, let us look at the theoretical value. Before we carry out the practical aspect, let's first of all look at the theoretical value. Why do we get the theoretical value? Many of you don't even know what theoretical value is. Now, when you do your titration after your first titer, second titer, third titer, you take your average, say that is your VA, right? But now we have not done the experiment, we have not carried out any titration, but with the value they give here, I will use this value to get my VA, and that will serve as my what? As my range. As my range. Now, let me teach you how you can calculate your your average titer value or the theoretical titer value. Now, before you can calculate the theoretical titer value, what do you need to do first? We record this formula. We said that molarity is equals to what? 10, the 10 here is constant, times you multiply by percentage purity of the acid. Then you also say times the specific gravity, then all over what? All over molar mass of the what? Of the acid. And in our guide here, what did they give us? They gave us HCl as the acid. So we are going to titrate HCl against NaHCO3. That is sodium hydrogen tricarbonate 4. That is the titration. And okay, don't worry, I will write everything here. So we have C equals to this concentration. We have to look for the concentration of our stock acid. So we have 10 times, we are using HCl. Percentage purity for HCl is about 36. Then times the specific gravity of HCl. Please make sure you check your HCl bottle. The specific gravity is written on it. Just check it. Carry the bottle, read the paper there, the instruction there. You see the specific gravity of the one you have. So the one I have here, the specific gravity is 1.18 all over what? The molar mass of HCl, which is what? Which is 36.5. Then we now have C is equals to, let's quickly multiply what we have here. We have 10 times 36 times 1.18. So this will give us what? 424.8 all over 36.5, which is equals to what? Divided by 36.5, we have 11.638. We have our mole per dm cube. Having done this now, we have to use this our dilution formula. We say that C1V1 is equals to C2V2. So we are looking for, let's substitute. Let's take this as our C1 and we have 11.638 times, if you check your instruction, this is your instruction guide. So once you check, you see that they said that you should measure 8.6 cm cube of concentrated hydrochloric acid. So that 8.6 now you put it here, 8.60, then which is equals to, we are looking for C2, which is the concentration of this. Then times, we are going to dissolve it in our volumetric flask. That is 1000 cm cube volumetric flask, or 1 bm cube, or 1 liter. So that 1000, that is okay. I will get it now. So that is the 1, 2, 3. So what do we do here? Let's quickly multiply this figure here times 8.6. We have 100.089. So I decided to use almost all the number. Then you now have 1000 C2 1000 C2. You divide both sides by 1000. You divide both sides by 1000. Everything here just divide by 1000. So my C2 here becomes what? 0.100 mole per dm cube. Are we together now? So that is, we've gotten our C2 now. You see this C2 now, this is going to be my Ca, which is equal to 0.100 mole per dm cube. This is my Ca. Then Va is the average titer value, which is the volume of acid used, which you will titrate to get. But I want to get it through this theoretical value. This is what I will be looking for. Then what else again? Cb. I need to look for my Cb. How do I get my Cb? What do I do here? I will say that mole is equal to what? Mass over what? Over molar mass. What is our mass? You also check your here. You check here. Then the mass of our base here, the one they say we should measure, the one we will use for the titration, is 8 gram of NaH. Then the mass is 8 gram, is written here. Then all over the salt, which is the base, is NaHCO3, which is this one. So what do we do next? We now say this is equals to 8 over, if you look for the molar mass of this one, it will give you what? 84 gram per mole. We have our 84, which is equals to 8 divided by 84. 8 divided by 84. What do we have? We have 0.095. 0.095 mole per dm cube. Our Cb here becomes 0.095 mole per dm cube. Are we together? It's very simple. So the next thing we need to do here now is to write the equation. Then the next thing we need to do here is to do what? Is to write the equation. Now the acid is what? The acid is HCl aqueous, then plus NaHCO3, which is the base aqueous. It will react to give me what? NaCl aqueous plus H2O plus CO2 gas liquid. Then what is our mole ratio here? Our mole ratio here, hydrogen is 2 here, hydrogen is 2 here, chlorine is 1 here, chlorine is 1 here, sodium is 1 here, sodium is 1 here, carbon is 1 here, carbon is 1, oxygen is 3, oxygen is 3. The equation is balanced, so our mole ratio is 1 ratio 1, ratio 1, ratio 1, ratio 1. So we are merely concerned with acid and the base. So what is the mole ratio now? Number of mole of acid is equals to 1. This one is this one. The number of mole of base is equals to what? 1. Now, if you look now, we recall our titration formula CaVa over CbVb equals N into A over N into B. So if you check now, you see that I have this. What is my VB? VB is equals to, your pipette is either, your pipette, the one used to suck base, is either 20.0 cm cube or 25.0 cm cube. Most schools use 25.0 cm cube. Even our school here, they use 25.0 cm cube. So my base now, volume of my base is going to be what? 25.0 cm cube. So if you check now, you see that I have this, I have this, I have this, I have this, I have this. So I'm going to substitute to get this. So I have to make this the subject of the formula. So let me make it subject of formula. Then I can just cross multiply by saying CaVa times NB equals to CbVb times Na. So I'm making this as a formula. Just pick this. Va is equals to what? CbVb Na all over what? CaNb. So let's substitute. What is our Cb? Cb is what? 0.095 times, what is our Vb? Vb, look at Vb here, is what? 25 times N into A is what? 1. All over, don't forget, here's my VA. All over, what is this? CA. So look at CA here. 0.100 times NB is 1 is equal to what? So let me quickly do 0.095 times 25 times 1 is equal to what? 2.375 all over this one times 20 is 0.100. Then divide by 0.100. Our VA is what? Is 23.75 cm cube. So 23.75. Our VA is 23.75 cm cube. What this means is that when you are carrying out your titration practically now, this one will guide you. So the end point for this year's 2020, for this year's on practical, chemistry practical 2025, it should be within the range of, let me say, 20. If you can get 21 to 24, 25, I think you're on the safe side. Yes, because it might not be exactly 23.75. But this one is your guide. So our end point, if you get 21, you get 22, you are good to go. Because WAEC is even going to mark based on the teacher's word report. That is what WAEC will use to mark your student. So, but on your own side, your end point should be from 20 and above, maybe to 25. Thank you. If you find this video useful, please ensure to subscribe to my channel, and God bless. Bye.